HVAC 360, episode number 43, Freezestats. Hey, welcome back, everybody, to another episode of HVAC 360. I am your host, Matt Nelson. This week, we're going to talk about something that my blog gets a lot of searches regarding freezestats. Now, I mean, I can understand that. They're kind of a little bit mysterious in ways, but yet so essential to the proper safety, operational safety of a unit, especially in colder climates. You know, if you're in warmer climates or in Dubai or anything like that, you know, you may not necessarily have to worry about freezestats. But you know, the rest of us in climates where it gets a little bit chilly and we see snow on the ground every time and again, you know, it's kind of a critical piece, because last thing you want to do is wake up in the middle of the night getting a call saying, "Hey, there's water all over the place. We had a coil burst in your air handling unit." Now, that's what we're gonna focus primarily on. Freezestats in air handling units. We're not going to necessarily go crazy about, you know, freezestats in other different locations, whether it be in ductwork or whatever. But I just basically wanted to cover the basic installation and operation of a freezestat. It's a little bit nebulous because, you know, frankly, you get into these smaller control devices and they seem rather simple, but, you know, there's not a lot of explanation out there to go through. And, you know, from what I've seen out in the field, it is just amazing. You know, I read all the literature and I compare Johnson Controls to Siemens to Honeywell to whoever, you know, whoever's the freezestats that I'm looking at. And, you know, they all are pretty much very consistent. They're very close together. You look out in the field, it's like somebody just threw up on a coil. You know, they just, you know, whatever floats your boat. They're trying to be artistic. They're just stringing this capillary tube wherever they want. And it's really I mean, it's bad. It's worthless. You basically nullify any sort of value that these freezestats can actually offer. Now, I call them freezestats. They go by many different names. Whether you want to call them low temperature cutout devices, low limit devices, low temperature detection devices. Vapor filled capillary tubes, whatever you want to call them. I'm just going to call them as a generic term of freezestats. Even though that might not be the proper term. I think the proper term probably would, if I had to pick one, I'd settle on low temperature cutout devices. So, but freezestats for now, it is. So, I just want to first start by putting a disclaimer out there. I have seen a whole bunch of freezestats, but I've installed a grand total of 0 freezestats. So I don't really come from a practical experience of actually installing it, but I do come from the standpoint of seeing bad ones, seeing them misapplied, seeing them not work properly, and frankly, doing my homework and just reading up on exactly what the installation instructions do say. So let's start off by digressing a little bit and dissecting the components of what makes a freezestat. Well, you start off with a body. You have the body, the sensor body, and it is attached to a capillary tube. Essentially, those are the two elements. Not very complicated again. So let's talk about the body first. The body has a couple different components. Typically, you're going to see the capillary tube coming out of the bottom of them, and, you know, sometimes when they're packaged, the capillary tube's like, you know, all twisted up. But the body has a adjustment screw, usually a set screw of some kind, so you can pick the exact range. We'll talk about that a little bit later. The exact temperature which you want it to trip at. It's going to have a electromechanical contactor switch that's going to be in there to activate the alarms and shut down the unit. It's going to have a bellows. That's what's at the end of the capillary tube. That's what actually enables that. That's the mechanical action that enables that electro mechanical switch. and then they usually have some sort, and this is kind of where it gets a little bit variable, whether or not they have a manual reset, whether they have a test button, and sometimes they're one and the same. Sometimes you might not have any of that. So depending on the manufacturer that you get, those are kind of the variables that you can have. But most commonly, you're going to end up with a test/reset button on the outside of the unit. So first question you got to ask, where do you put the body of the Freezestat device? Well, you want to put it on the top of, not literally the top, but basically on the vertical face of the unit. You want to put it up pretty high. Obviously, you don't want you want to have the capillary tube coming out of the bottom of it, so you want the capillary tube going down. But you want to place it about as high as you can on the outside of the casing. The coverage of the capillary tube, now kind of switching over to the capillary tube. Capillary tube is a thin tube, and just to kind of stop and explain a little bit, if you're not sure, if you go up to an air handling unit, you're not sure exactly what you're looking at, there's two different types of tubes that you really find in air handling units. There's the mixed air sensor, some sort of temperature averaging device, or this low limit cutout. The Freezestat low limit cutout tends to be a thinner tube. So if you're kind of wondering exactly what you're looking at, if it's a thinner tube, more than likely it's going to be the low limit cutout, the Freezestat. So the way you're supposed to design these things, the coverage goes that 1 linear foot of this Freezestat covers approximately 1 square foot of coil. So if you kind of extrapolate the math here, these capillary tubes typically come in, you're going to find them in 20-foot lengths. There are also options for smaller ones. Some manufacturers sell them in 10-foot lengths. Some actually have 6-foot lengths. So it depends on what manufacturer you're dealing with. Those are kind of 3 of the common lengths that you can get for these things. But so you have a 1 linear foot to 1 square foot ratio. So that if you had 20 linear feet of this sensing element, you can cover about 20 square foot of coil. Now, 20 square feet of coil, and you do the engineer's average of, okay, say you had a standard face velocity of 500 feet per minute. You come up to a quick number of 10,000 CFM for an entire unit for one Freezestat. Now, that's kind of important because you got to think about the layout of these things because you can end up with multiple Freezestats on a single unit. I've seen units that were so big that they were actually served by like 5 Freezestats. Now, most of those probably aren't going to see a lick of duty, but you really need to have that coil coverage just in case. So, like I said, you could end up with 5 if you have something that's 50,000 CFM. So, not to say, and of course, not to say that if you had 11,000 CFM, that one sensing element wouldn't necessarily cover the entire coil, but it's just something that you need to be aware of. Typically, as a commissioning agent, if I see a poorly covered coil, I'm gonna request that additional sensing elements be placed on the coil to get that proper coverage. So now we have the critical component, and I guess this probably comes into play most often, or maybe this is stems of a lot of the questions. Where do you put the darn thing? Yeah, where does the sensing element go? Now, typically, and we're talking air handling units here, you're either going to have 1 or 2 coils. Typically, if you have one coil, it's going to be on the downstream side of that coil, and in general, it's going to be on the downstream side of any coil. So if you have a heating coil and then a cooling coil, so you have the heating coil in the preheat position, you're going to have it on the downstream side of that heating coil. So off the heating coil, you're going to have that Freezestat to protect the cooling coil. If you just have a cooling coil, you're going to put it on the downstream side of that cooling coil. Now, of course, I have to take one step back here. I am talking about water coils. I'm not talking about DX coils. It's not necessary. They're not gonna burst. So this is only talking about water coils. So if you only have a cooling coil, it's going to go on the downstream side of that. Alternately, if you have only a heating coil, it's going to go on the downstream side of that, regardless. So that's where you're going to want to put it. Typically, you're going to have, and I've seen this in cases where the averaging sensor for the unit actually got switched. So it was on the downstream side, and the freezestat was on the upstream side. So that's a no-no. You want to be able to have those switched. Typically, they're not going to put two sensing elements on the same side of the coil. So you want to have the freezestat on the downstream side of your coil. All right, now we have that explained. When you enter the casing, so you have the thing mounted, you're gonna put the tube through the casing. Typically, you're going to drill a hole through the casing. Now, that's going to be kind of a sharp edge. It's not going to be smooth. You're going to have it's going to be kind of rough there. So you want to make sure that you're going to put some sort of grommet, some sort of a cover on the sensing element as it goes through there. Typically, you might what I've seen a lot of lately is just you're going to have some sort of rubber casing that goes over it just to protect it. So the thing that you want to be concerned about, and why this even matters, is that if the sensing element vibrates at all, obviously you have the fan and in the air handler, it's going to move a little bit, and you don't want that minute movement to etch away at the outside casing of the tubing, because eventually it's going to fail. So, and then you have to replace the element because it's gonna lose all its pressure. So, very critical to have that when you penetrate the casing, to have that grommet. I've seen it missed, excuse me, a whole bunch of times. Now, you're inside the unit. How do you lay this out? Okay, now up until now, usually most people get it, are pretty good at it. Now the artistic side of these, whether it was installed in a factory like that, or whether the controls contractor installed these things, this is where it gets artistic. And from all the literature I've seen, they've only said one way. You want to have the layout, and I'll say this slowly for emphasis, in a downward horizontal serpentine. That means it's going from side to side a whole heck of a lot more than it's going top to bottom. So you want to be able to cover basically, and you're going to space, the tube is going to be, it wants to be a foot apart, obviously, because the foot of coverage kind of says, okay, 6 inches down, 6 inches above, that covers the coil for that square foot. So you're going to have, between the different rows, you're going to have about a foot of spacing, and you want to be able to end your last row of the sensing element. You want it 6 inches above the bottom of the coil. All right. So it's very critical now that you don't crimp or crush or pinch the element. This tube, it's a thin tube, so it's really easy to you manhandle it a little bit and crimp it. But what that effectively does is, at the point where you crimped it or crushed it, that's where it ends. That's where the sensing element ends then. So you don't get, and since the end of the element typically is on the bottom of the coil where you need it the most, if you crimped it anywhere before that, you'll lose the coverage of the bottom coil. So you're gonna want to be careful and not pinch it. If you're inspecting it, you'll want to look for that. You just kind of follow it back and forth and make sure that it's going back in that serpentine manner, and it's not crimped or bent or anything like that. So when you're going back and forth along the face of the coil, typically there's going to be some sort of metal angles that you're going to be able to tie off on. There again, you want to be able to secure it. A lot of times they're going to have the manufacturers will actually have pre-made bends for you. They're made of plastic. I've seen some made of metal. I don't think that's a good idea. You get the metal on metal contact. You get some corrosion. Obviously, it eats through the eats through the metal tubing, and there you lose your element again. So, but the plastic, obviously, that's not going to have any sort of catalytic reaction to the metal on metal, as opposed to the metal on metal. So those are the nice sweeps. They give you the nice sweeps, so you don't have the sharp bends. So you take those and use those on the ends. Sometimes they're going to have standoffs where you're crossing those bracings, those angles along the coil facing. So you're going to be able to tie it off on there. And two, it's important to remember. Again, you want to have when you're doing that turn, you're going to want to have some sort of protection. If you're gonna zip tie it to the coil facing, you're gonna want to have some of that the rubber tubing surrounding that, protecting that, so you're not accidentally tightening it too much, or you want to be able to cushion that and be secure yet not too firm. So you've got it placed back and forth, and I realize if not having installed one of these things and knowing that, what I want that last, that 6 inches off the bottom of the coil, I want that whole row to be perfect. And then you work your way back, like Christmas tree lights. I tend to go, down and up, and, you kind of have to get the space and get the feel for it a little bit. So that can be a little bit difficult, but it's well worth it. Try not to, try to use all the lengths. Try not to, just tie it back to itself. Again, you're in danger of crimping that and, getting improper operation off of that. So now you have it installed correctly per the manufacturer's recommendations. Now what? Well, now you got the operation of the unit. Okay, the operation is relatively simple. The manufacturers state that typically 12 to 18 inches, any section 12 to 18 inches of that tube, it goes below the set point that you've set, you're going to have the unit trip. Now, when that unit trips, when that switch trips, two things are going to happen. You're going to open the contactor that kills the fan, and when the fan goes, the whole unit goes into a unoccupied setting. So outside air damper closes, return damper opens, fan shuts off, the valves go into their normally closed position. Now typically that's going to be heating valve open, cooling valve closed. So all that should go into an unoccupied setting. And then the second thing it does is it closes a signal to the building automation system saying that we have an alarm. So opens the fan contact, closes the BAS contact. So, and that is the same thing again. When you want to test a unit, you're going to go up there and you're going to hold the button. Sometimes it's a two-person job. That's a better way to do it, because one person can check out the unit while the other person holds it. These test buttons, typically, you don't press it and then it goes off. You have to hold it there. So my rule of thumb is carry change with you when you do the testing. That way you can pull out a quarter nickel, whatever you have in your pocket, and you save your thumb that way. So you can press down on that button and hold it for the minute or two that the other guy is checking it out. So that's my tip for the day on the on testing. So typically there's going to be two types of these Freezestats. There's going to be the manual reset and the automatic reset. Now, I'm a big fan of the manual reset because that kind of mandates that the operator gets off his duff and goes to check on the unit itself. So if something went wrong and the unit tripped off, they're there to say, okay, you know what, I see the reason, let's correct it, and then they'll reset the unit and let it go on its merry way. If you have an automatic reset, that can be bad because, again, you're talking temperature here. So if the unit trips off and there's an automatic reset, so it warms up a little bit, trips off again, warms up a little bit, trips off again, you could still have a potential to freeze out a coil. So manual reset, I'm always in favor of the manual reset. Obviously, there are some conditions where you're going to get away from that, but again, by default, I would just have a manual reset. So, now the exciting part, and this is I dig deeper. I'm like, okay, well, you say 12 to 18 inches and the unit trips. Okay, why? Why does it do that? Well, here's the science behind it, which, I like. You have this capillary tube filled with vapor. Now, this vapor is basically put into this capillary tube, and it expands, and it opens the bellows. The bellows is kind of on the end, so it just kind of puffs out the bellows as it expands. When you cool this vapor, it condenses into a liquid and changes the pressure. So it condenses, it's basically kind of sucking in now, and that bellows collapses and makes the contact. So that's how it technically happens. So you have the liquid or the vapor that expands the bellows, and then when it goes below that set point, it contracts, and that bellows makes that contact trip. So that's the interesting part of it. And again, you can kind of see where if you crimp that, then the vapor that it sees, it only sees the vapor that's in between the bellows and the crimp. It doesn't see the after the crimp. It doesn't care about that. If that turns into liquid, then it's just going to be fighting against the pressure of that the joint or where the crimp is. So, what's important to know about freezestats, and why is it that everybody needs to know more information about them? Freezestats, improperly applied, are going to have nuisance trips, and this is a bad thing because the freezestat in and of itself is does the perfect job. I mean, it's perfectly applied. It's the right technology. Obviously when installed properly, and it really does the job, and it's really reliable. Well, if it doesn't, if it's installed improperly, or there's something wrong with the design where you're constantly tripping the freezestat, now you have the building operator losing faith in this. It's the whole boy who cried wolf syndrome. If the freezestat trips off, so what? You can get freezestat that are bypassed, are not used, are held open, are rewired, are taken out, disconnected, and then you're back to no protection for your coils, for your water coils that are in the unit. So you want to make sure that they're tested correctly and they're installed correctly, so you can avoid this the nuisance trips and things like that. So typically, you're going to have on the nuisance trips, the reason obviously that you want to protect the bottom of the coil is that cold air settles to the bottom of the coil, and whether the sometimes when the outside air damper might be a little bit open, or you have the outside air damper coming in the back end and the return air coming in the top, you're going to get the stratification effect where the outside air just hugs the bottom of the unit. It's going to hit the bottom of the coil, freeze it, bust a coil, water all over the place. So if you have the freezestat there, to shut down the unit if you don't get that proper blending, and you can settle it like that. But there again, if you have that configuration and you don't modify, you don't get that air turbulated anywhere, just mixed up anymore, you're going to have that problem. Or sometimes, in I've seen cases where if you've had energy recovery wheels, if you had a bypass that's on the bottom of the energy wheel that's open, sometimes you get that stratification effect that way too, and it hits the bottom of the coil, trips off the freezestat. So you want to be able to solve the why. Why is it tripping on to avoid these nuisance trips? So you want to get something that, in fact, if it trips, there's a bona fide reason why it trips, and they can deal with it then. So you want to make sure that you eliminate the nuisance trips. That has got to be the bane of the freezestat's existence. All right. Well, that's it. That's all I have. I hope that was a good enough explanation. I'm going to leave some links on the website to some PDF material, so you can see for yourself and look at the installation manuals. I'm not making this stuff up. But so that's it for this week. I appreciate each and every one of you listening. Thanks for tuning in. If you enjoyed this, please let me know. If you have any suggestions, you can give me a holler over at matt@buildingx.co, or you can follow me on Twitter at buildingx. So that's it for this week. Any suggestions? Let me know. Otherwise, until next time, remember, know what you build and share what you know.